So, can one single laptop handle millions of users streaming Netflix at the exact same time? Yeah, obviously not. If you've ever gotten that dreaded storage almost full message on your phone, or, if you've just wondered how major platforms push high-def video to millions of people simultaneously without buffering, well, you are brushing up against the massive scale problem that cloud infrastructure actually solves. I mean, just think about the sheer amount of physical hardware you'd have to buy, power, secure, and keep cool just to handle a fraction of that kind of global traffic. It is literally a logistical nightmare for any business. So no, your laptop definitely can't handle it, but Amazon EC2 absolutely can. Today, we are looking at the real engine behind massive scalability on the internet. You see, instead of dropping tens of thousands of dollars on physical servers that, let's be real, just end up sitting idle overnight, companies are leveraging AWS to rent computing power right on demand. It completely removes the burden of managing these giant data centers, which is huge because it allows developers to focus purely on building incredible applications. So welcome back to The Explainer. I am super excited to guide you through day 2 of our structured cloud learning journey. Today, we are diving deep into a complete beginner's guide to Amazon EC2. Seriously, if you're going to master AWS infrastructure or build any kind of scalable application in the cloud, this right here is exactly where the whole shebang begins. All right, let's take a quick look at the agenda. 1. From physical to virtual. 2. Introducing Amazon EC2. 3. Choosing your instance. 4. Building the virtual firewall. 5. The keys to the cloud. And finally, 6. Connecting to your server. Okay, jumping right into section 1, from physical to virtual and the shift to cloud computing. To really get this, imagine moving to a brand new city. You could go out and buy a car, right? But that means a massive upfront cost, paying for insurance, dealing with repairs, and, well, mostly just keeping it parked and totally unused for most of the day. That's the old way. That's on-premise servers. Or you could just grab an Uber. With Uber, there's zero maintenance, no upfront cost, and you literally only pay for the exact minutes you're sitting in the car. That is cloud computing. You're renting computing resources over the internet instead of buying physical hardware, and that just drastically cuts your costs and boosts your flexibility. And to make that whole Uber-style renting thing possible, AWS relies on a technology called virtualization. So a virtual machine, or a VM, is basically a software-based computer that behaves exactly like a physical one. AWS takes one massive, wildly expensive physical server, something with like 512 gigs of RAM, and uses a piece of software called a hypervisor to slice it up into a bunch of independent virtual machines. So you might end up with an Ubuntu machine, a Windows machine, and a Red Hat machine, all running securely side by side on the exact same physical hardware, totally unaware of each other. Which brings us to section 2, introducing Amazon EC2, renting space on someone else's computer. Now, the absolutely crucial thing here is understanding the acronym. EC2 stands for Elastic Compute Cloud. Compute is just your processing power, right? Your CPU and RAM. Cloud means it lives in AWS data centers, and you access it over the internet. But elastic? Man, that is the magic word. Think of a balloon. Elasticity means you can instantly expand your resources when a massive wave of users suddenly hits your app, and then you just gracefully shrink them back down when the traffic drops off. You aren't paying for wasted space when your users go to sleep. It completely flips the financial model of running an app. And when you interact with an EC2 instance, it goes through a very specific lifecycle. First up is pending. That's where AWS is busy carving out your virtual machine, behind the scenes. Then it hits running. This means the server is ready for you to install stuff, but, and you'll want to remember this is also where your hourly billing starts. Now, if you hit stopping, it shuts down the operating system. Your compute charges stop, but actually watch out for this. You might still get hit with small charges for the storage drive that's attached to it. It's a super common trap for beginners. Finally, there's terminated, which means the server and its data are permanently wiped out and all your billing completely stops. All right, let's move on to section 3, choosing your instance, selecting the right blueprint and hardware. So the very first choice you're going to make is selecting an AMI, an Amazon Machine Image. You can think of this as the foundational blueprint for your server. Instead of spending hours manually installing an OS and setting up dependencies, you just pick an AMI, say a clean Ubuntu server or Amazon Linux 2023, and AWS just stamps out a fully configured machine for you in seconds. If you've ever wasted a whole weekend fighting with software updates just to get a server to boot, an AMI is going to feel like an absolute superpower. Next, AWS categorizes all that hardware power into instance types. Now, as a beginner, your absolute best friend on this list is the T2.micro. It gives you one virtual CPU and 1 GB of RAM, but here's the best part. It is entirely free tier eligible. It is literally the perfect risk-free sandbox for learning. You can test out all these concepts, build a real server, and just experiment to your heart's content without worrying about some massive surprise bill at the end of the month. Moving right along to Section 4, building the virtual firewall, securing your cloud real estate. Because leaving a server wide open on the internet, yeah, that's a recipe for disaster. In AWS, your firewall is called a security group. Imagine your EC2 instance is an apartment building, okay? The security group is the giant digital fence running around the perimeter. And by default, AWS uses a zero-trust model. That means the fence has absolutely no doors. Zero traffic gets in, which keeps you totally safe from silly mistakes on day one. If you want people to see your website or if you need to log in to fix something, you have to explicitly and intentionally open very specific doors in that fence. And there are a few essential doors or ports that you absolutely need to know. Port 80 and 443, those are for HTTP and HTTPS, your standard web traffic. If you're running a custom app, like maybe a FastAPI Python app, you'd probably open port 8000. But listen up, pay incredibly close attention to port 22. That is used for SSH, your remote administrator access. You should absolutely, under no circumstances, leave port 22 open to the entire internet. You need to strictly lock that down so it only accepts connections from your personal IP address. Next up, Section 5, the keys to the cloud, secure access without passwords. So you've built the server and punched a secure door through the firewall on port 22. How do you actually get through it? Well, AWS doesn't use standard typed passwords for Linux servers by default, because honestly, they're way too vulnerable to automated hacking bots. Instead, they use a clever cryptographic system called a key pair. The public key acts like a very specific padlock that AWS just automatically bolts inside your EC2 instance. The private key is your physical metal key. You download it as a .pem file, and it lives safely and exclusively on your local laptop. When you want in, you present your private key. If it fits the public lock, boom, you are instantly granted secure access, and you never even typed a password. Let's wrap this up in Section 6, connecting to your server, bringing the journey together. If we just quickly summarize the launch sequence, it's exactly like building a digital house. Step 1, you pick the blueprint, like your Ubuntu AMI. Step 2, you select the size of the house, like a T2.micro instance. Step 3, you build the fence and open the doors by setting up your security group. And Step 4, you forge the key pair lock system and just click Launch. Once your instance state flips to running, you can command it using its public IP address. If you're on a Windows machine, you can use a tool like PuTTY to fire up an SSH connection using that .pem file. But honestly, even easier than that, you can use a feature called EC2 Instance Connect to open a secure command line shell directly inside your web browser. No managing local keys, no extra software. It just opens right up in a Chrome tab. And from there, you've got total control. Install Docker, deploy your databases, run your web apps. It's all yours. To cap off today's concepts, I really want to leave you with this fantastic quote from our source material. Building an app without cloud computing today is like trying to run a race barefoot on broken glass. Mastering this stuff, knowing exactly how to spin up, secure, and connect to an EC2 instance is just non-negotiable for modern software development. It makes innovation cheaper, faster, and globally scalable. When you master this foundation, you are literally putting the exact same power used by Netflix and Amazon right at your fingertips. But that does lead us to one massive question. Let's say your single T2 microserver is perfectly configured, it's live, your app is running beautifully. What happens if your app goes viral and 100,000 users try to log in all at once tomorrow morning? Your single server is going to completely choke and fail. So how does the cloud automatically add more servers to handle a massive sudden spike like that? Well, we are going to answer exactly that when we dive into autoscaling in day 3. Until then, keep learning and keep building.